Here are the answers for the Section 8-7 Day 2 assignment. Question 1. The frequency of a radio wave is inversely proportional to the wave's length. So our variables involve frequency of the radio signal and the wavelength of the radio symbol. We're told that they're inversely proportional. Let's choose variables to represent those concepts. Maybe F for frequency and W for wavelength. So from that first sentence, frequency times wavelength is equal to a constant. Now in the second sentence, the wave is 250 meters long. That is a wavelength, and it has this frequency. So with those two values, we can solve for K. For frequency, fill in the 1200, and for W, fill in the 250. And that's equal to K. Now multiply those together on a calculator. This turns out to be 300,000 is equal to K. Now we're able to write the model for the situation. Frequency times wavelength is equal to 300,000. Reading farther, find the length of the wave, so find the W when the frequency is 800. So for the letter F, fill in 800. W is the variable, and over here, the 300,000. To solve for W, divide by the 800, and that'll get us our answer, 375. In the story, wavelength was being measured in meters. Number 2, a pulley with diameter 8 inches is running at this many revolutions per minute when it's connected by a belt to a 12-inch pulley. So we had one like this in our notes, a smaller diameter pulley, a larger diameter pulley with a belt or chain that was connecting them. Find the speed of the larger pulley if the speeds of the pulleys are in inverse proportion to their diameters. So speed and diameters are inversely related. Let's choose some letters to represent things. Maybe D for diameter and maybe S for speed. So diameter times speed is equal to a constant. When the diameter was 8 inches, the speed was 1452. Multiply these together to get the answer for K. It's 11,616. So our model relating diameter and speed of these two pulleys is D times S equals 11,616. The question is, find the speed of the larger pulley. So find S when the diameter is 12. Divide both sides by 12 to get the S alone. 968. And speed is being measured in revolutions per minute. That's RPM. Number 3. Two meshed gears have 35 teeth and 56 teeth respectively. If the speeds are inversely proportional to the number of teeth, at what speed should the second gear be driven so that the first gear will run at 1450 revolutions per minute? So this question involves two gears of different sizes. It's a lot like the one with the pulleys. It's just that the gears physically touch each other so that the teeth can overlap instead of the pulleys being separated but connected by a belt. We're told that speeds are inversely related to number of teeth. I'm going to use S and T as variables. S times T is equal to a constant. We're told that the first gear runs at a speed of 1450, and the first gear had 35 teeth. So for the letter S, 1450. For the letter T, 35. Multiply these together to figure out K. 50,750. So the model is S times T equals 50,750. We're asked, at what speed should the second gear be driven? The second gear has 56 teeth, so we want to solve for S when T is 56. To get S alone, divide by 56. S equals 906.25. And the speed of this gear is in RPMs. Number 6. The heat developed in a wire carrying a current for a specific time varies jointly as resistance and square of the current. We're told that the heat varies jointly with the resistance and the square of the current. It doesn't say varies inversely. It says varies jointly, which means a direct variation. So heat is equal to some constant times resistance times current squared. Let's substitute known values to figure out K. In this sentence right here, it says a current of 8 amps, so for the letter C, fill in 8, produces 153.6 calories, that's a measure of heat, in a wire whose resistance is 10 ohms. So for the letter R, fill in 10. The variable we haven't filled in is K. Let's solve this for K. So divide by 640. Where I'm getting the 640 is 10 times 8 squared. The result is 0.24 is equal to K. Now let's rewrite our model. The heat is equal to 0.24 times R times C squared. Now go to the last sentence. How many calories? So that means figure out H when we know values for the other letters. The resistance is 15 ohms and the current is 6 amps. Take a calculator and work out that answer. The result is 129.6. The heat in this wire is being measured in calories. Number 7. A surface is now 10 feet from a source of light. How far from the source would the surface have to be in order to receive twice as much light if the intensity of light varies inversely as the square of the distance? Hopefully you recognize this problem was done in our notes as a sample. Let's make our model. And for variables, let's use D for distance and I for illumination. It says the illumination varies inversely as the square of the distance. So illumination times distance squared is equal to a constant. In the first sentence, we're told the distance is 10. But we're not given a value for illumination. Let's just choose a value. So for illumination, I'm going to choose 1. And for distance, 10. 100 is equal to K. Now we can write our model. Illumination times distance squared is always equal to 100. The question is, what distance is needed to have twice as much illumination? Because I chose 1 for illumination last time, I'm going to choose 2 this time because that's twice 1. Now solve for D. First step, divide by 2 on both sides. D squared equals 50. Second step, square root. D is equal to the positive square root of 50. That's approximately 7.1. And distance is being measured in feet. Number 8, when an object moves in a circular path, the centripetal force, use letter F, varies directly as the square of the velocity and inversely as the radius. Let's make a model from that. Force is equal to some constant times velocity squared, but then divided by radius. Then we're given values to substitute in that will allow us to figure out k. So for f, 64. For v, fill in 2. And for r, fill in 5. And solve this for k. First step, multiply both sides by 5. 320 is equal to k times 4. I'm getting the 4 from the 2 squared. Now divide by 4 on both sides. 80 equals k. Now we can create our model. Centripetal force equals 80 times velocity squared divided by radius. The actual question says, find f when you know these other values. So let's substitute. For velocity, fill in 3. And for radius, fill in 4. Take a calculator and type this in. The result is 180. This question does not give us the units of measure for centripetal force. And it also doesn't tell us in what units velocity or radius are being measured in. So we have no way to give a specific unit of measure. All we can do is say 180. Number 9, if a satellite completes an orbit in 90 minutes, flying 500 miles above the Earth at this speed, how long, so how many minutes, would it take a space capsule flying this height above the Earth at this speed to complete one orbit? To help us do this, we're told that the radius of the Earth is 4,000 miles and that the time in hours for a satellite to complete one orbit varies directly as the radius of the orbit and inversely as the orbital velocity. Let's choose some variables to keep track of the different ideas within the problem. One idea is the period in hours for a satellite to make one orbit. Period is the amount of time. I'm going to choose t to represent that. Another idea is the radius of the orbit. Let's use r for that. And another idea is the velocity of the spaceship as it's orbiting. Let's use v for velocity. And let's create a model from this last sentence. The period, so t, is equal to k times the radius of the orbit, so times r, but then inversely with velocity, so divided by velocity. Let's make some substitutions to solve for k. In the very first sentence, we're given some values. The period of time for one revolution is 90 minutes. But remember, later we were using the letter t to be time in hours. So when it says 90 minutes, that's the same as 1.5 hours. Fill that in for t. Now the radius. We're told that the satellite is flying 500 miles above the Earth, but that 500 miles is the distance above the surface of the Earth. What is the true radius from the center of the Earth? And that's where the 4,000 miles comes into play. If we make a quick sketch over here of planet Earth and put a dot right at the center, it is 4,000 miles just to get to that spot. And then the satellite's out here flying around the Earth in its orbit. That's an extra 500 in between there. So the true radius mentioned in the first sentence is 4,500. And the velocity is 18,000 miles per hour. Let's solve this for k. 1.5 times 18,000 divided by 4,500. And the result is 6. So now we can make our model. T equals 6 times r divided by v. Now go more to this part of the problem to get some additional values. We're asked for the time, so t is the variable we want to figure out. And this time the radius is 4,000 plus 300, or 4,300. And the velocity is a little bit faster. This satellite is going 18,950 miles per hour. Type this in to solve for t. And the result is 1.36 if you round it off. This time is being measured in hours. Number 10. A gas whose volume is 500 cubic centimeters is under a pressure of 30 inches of mercury at a temperature of 300 degrees. What pressure would be exerted by the gas if the volume increased to this volume and the temperature dropped to this temperature? To help us with the model, we're given this last sentence, which you would learn in a chemistry class. The pressure on a gas varies directly as its absolute temperature and inversely as its volume. Let's use P for pressure, T for temperature, and V for volume. Pressure equals some constant times temperature divided by volume. Let's fill in our values from the first sentence to figure out K. It says a pressure of 30, so for P, 30. It says a temperature of 300, so for T, 300. And it refers to a volume of 500. Solve this for K. 30 times 500 divided by 300. The result is 50. So our model is P equals 50 times T divided by V. We're asked, what pressure, so we want to find P, for a gas that has a volume of 570 and a temperature of 285. Type this in the calculator to get the answer for P. And the result is 25. This pressure is being measured in inches of mercury. Number 11. The weight of a body is inversely proportional to the square of its distance from the center of the earth. So one concept is weight, let's use W for that, and the other one is distance. So weight times distance squared is equal to a constant K. The weight is 147 pounds on the surface of the earth. So on the surface of the earth, the distance is the 4,000 miles. Type this in to solve for K. And the answer for K is a really large number, 2352, with 6 zeros after it. In a science class, your teacher would want you to put that number in scientific notation. Let's make our model. The question is, what will he weigh? So we want to find W when he's 200 miles above the Earth. So the distance from the center of the Earth is 4,200. To solve for W, you have to divide by 4,200 squared. And the result is 133 1/3 pounds.